Welcome to this talk. We are going to try to teach you what are the backbone behind the Async JS. These are concepts that help us understand how are we programming and how everything is working behind everything. So it's good to learn the things that are not included in the framework. So what I want you to understand is understanding something very basic, such as data structure, but you also have to understand how the ecosystem of the language works. So this is why we're going to see different topics. First is callbacks and how we handle things with all the browser APIs. The promises, that it is a new thing of tracking everything that's going on. Iterators, that it is a new way of having the usual loops that we used to do them strictly, like how step by step the machine had to go for it to be able to grab that data structure. Then generators, that's a new part of JavaScript that tells you that you can have functions that can be paused. And the async await method that gives us a little bit of legibility about how we are doing all this asynchronicity in our programming. And finally, we'll reach conclusions about when we should use each one. So to be able to start, so our approach is going to be callbacks from an asynchronous point of view. To be able to understand this, we are going to see how the ecosystem of JavaScript works. JavaScript is single-threaded, speaking strictly about running, because maybe they have a service worker with another thread, but this is purely the running of our code in our browser. And this is going to be running asynchronously. So we're going to go line by line, seeing what we can run, ignoring comments and other notes. And that part is going to have to end, the entire function would have to end to continue to the next line. So what we have to understand here is that it has a run to completion behavior, which means that I am not going to go on to another part of the code until I don't complete this part that I'm currently running. Someone who hasn't used JavaScript would say, well, if I have to complete everything, then I am going to complete the screen and the user will not be able to interact with it when entering their credentials, and it's not going to be a good user experience. So what is going on if you really have to complete everything in only one place? Because as we said, we will always have to wait something from a server because we are on the browser side, so we need to grab all this information. So we have something that it is called the callback stack, the call stack, the memory variable environment, and the thread of execution. This is going to be reading all the lines of code that we have, and the memory variable environment is how it's going to be replicated different scopes that we're going to put in our programs, and the call stack is all the functions that are going to be accumulating to be able to run them. Besides this, that is just JavaScript, we have something else that it is the browser APIs. This gives us access to their timers, to the document, and a lot of events that we can use, but they are not really JavaScript. They are a facade, sort of a browser extension, so that we can use it as if it was a native JS language. Besides that, we have the event loop. So if you haven't heard what this means, this is a program that is executing and it's looking at what kind of asynchronous functions are still to be executed if and only if no synchronous code has finished executing. So in that way, we can have a way of how to look at the code. Here is a small example of code in which we're going to create a function called print hello. And we are going to send it to a set timeout. This is a facade of what I have said about the APIs in the browser. This is not only available in the JavaScript, native JavaScript. And what this API does is sending this function to a queue. And this is going to run when the condition of 1,000 milliseconds having elapsed is fulfilled. So it's not going to be called after 1,000 milliseconds, but it's going to be sent to the queue after those milliseconds. So if there is no synchronous code running, then it's going to be sent to the call stack to be able to run. So if we read from the line 1 to line 8, we can see that the only synchronous code that is not using the callback is the console log. So that is going to be sent directly to the call stack and print the final hello. And then after that is going to be to print the line 6 and line 5. And just to clear out what's going on, this is for all DOM events. So when we click, this synchronous event is going to be happening. So every time the synchronous code is going to be happening, this is going to be checked, not before and not after. So every timer that is not resolved immediately are going to have to wait to synchronous code to run. Oh, I missed you a bit. Can you still see me? Yes, okay. And in this way that I'm showing you here is how exactly the scope is going to be cached. So that is going to be the memory heap. The hoisting, which is something else, you can see what the different scopes are and how the memory is going to be allocated to your program. With this, we're going to see the functionality of callbacks. Now that we have understood this, the negative part is that we do not have a tracking of what is the status of that function that we sent. So it's going to be, this running is going to be completely from the API that we are using to run it, not from our side. So that gives us a problem of inversion of control. So this is why we have these new things called promises. I call them new, but there have been here for a long time. But this is the next thing after callbacks. And now promises gives us from the JavaScript side a way to follow up the status of the function that we sent, either pending, resolved, or maybe an error. And in that way, we can counterattack what's going on. And we are going to send the kind of callbacks, but we have a cleaner way to do this, because we have a function now that is called then, and we can send an array of functions that tell us what are the possible solution of what's going to happen after that function is solved. And a catch property that can let us add all the errors. So this is about adding stuff. It is not about it being run and then being sent to the then function, but it is a reference of what functions can we run when this had happened. So to be able to understand what's going on, we're going to use it with fetch. This is a promise that it's already included in the browsers. And what it does is to grab an XHR to anywhere and grab the information back. So this way, what we do is give me this information, and I will tell you what you're going to do when you are complete with a callback function, either in a state of correct or in a state of error. I'm just going to load the following page. When we are calling a promise, we are going to have the value, which is going to be returned when it's fulfilled, and the unfulfilled, which is the array of callbacks that we send with .then with that promise. And every time the value changes from undefined to something, that array, that unfulfilled array, is going to be calling each one. So since we only have one .then, it's going to be calling only one function. So this way of handling errors is a little bit cleaner, because we only have to add functions to .catch, and we don't have to do something ugly, like we don't have to send the array the tree of callback hell that is just nesting the function until there's a pyramid. So we have some legibility for this part. So we're going to analyze how is the execution of this part, combining it with what we saw about callbacks. So if we see from line 1 and line 2, we are creating a function which is going to print whatever we put there. And the second is that it's always going to print hello. The third line, we will add a call to the timer API, which is going to create that print hello directly. As we know, it is an asynchronous function, so it's going to be sent to the queue of asynchronous things. Since it is indirectly fulfilled, it'll go in the queue, so when there's no synchronous code, it's going to run. Then we'll go to a function that is going to completely block the thread. So it's going to be very complex. It's going to make a lot of calculations. It's not just synchronous. It's going to be an infinite loop of maybe 8,000 recursions, and it's going to block it by 5 milliseconds. Then we're going to assign a promise to the value of feature data. And as we remember, we need to add a callback to this promise so that when we receive the return value, it can act with that value. So this is why we add this .then print, so that when we receive that data, we can print it in the console. Since it is an asynchronous function, until it is resolved, we can add it to the queue. Let's say that it is a stable server that is we're going to take like a second to receive that response. After that, just as we solve directly the timer with a 0, we're going to be able to solve a promise with .resolve directly, and then add the handler that is going to have when it's solved. We placed here .resolve, and then the data that we're going to resolve, that test value is going to be printed in our function print. And since it is asynchronous, it's not going to go directly to the call stack, but to the queue. So we're going to block again the thread by 5,000 milliseconds. So we are going to block that function. And that function that was going to take 1 second is going to be fulfilled, and it's going to be sent to the queue because the condition to be added already happened. And finally, we had something synchronous that can be executed directly, which is going to go directly to the call stack, and we're going to see our console, our first message, which is going to be final. And we're going to see this little box here, which is going to be our console to see how things are going to happen. And seeing things with print hello, we see that print hello is printed until the end, but it was the first that was added to the queue. So this is a very strange behavior because we specifically told us that it was the first thing that was going to be resolved, but it was resolved until the end. Why does this happen? Because there are two types of queues. The first queue is directly for all the promises, and the second is for callbacks. This let us say that all promises that we're going to solve are going to have a higher priority to all the callbacks that I'm going to have. So if you remember, we did the first, which went through the normal queue, and all the promises went to the higher priority. So this is why they were printed earlier. So what is going to be the development of the event loop in our JavaScript applications? So I'm always going to try to run the main thread, which is always the synchronous code, and the asynchronous code, I'm going to send it until there is a condition that can add it to the queues. And if I ended up reading all the synchronous code, I'm going to check what is going on in the microtask queue, which is the one from the promises, and see if there's something that can be added. If there's nothing to be added, I will check the callback queue, and if there's something there that we can add to the call stack, we put it there. And if those queues are empty, well, the program will finish. That is the behavior that normally all JavaScript applications have. With that, we complete what is going on, and then we will analyze how the async await was created to have better legibility between developers. First, we have to see what are iterators and generators. For those who do not know, an iterator is a new way to receive information from a data structure. And instead of we going with an index and a counter going element by element grabbing all the information, I will tell it, give me information when I need it. This give me information is going to be through a protocol that's already established. This is called next, and this method is going to return a value with and a completed. If the completed has something, then you won't be able to call anything from next, and the value is always going to return what it has. And until the value is undefined, completed is going to be true. So this is the way in which we are going to create this iterator from scratch. This is using something that is called closure. If you do not know what it is, this is all the functions that return other function that persist in a state that we have. This is the easier way that I have found, but since it is a little bit complex, everyone is going to have its own definition. So it can be developed further, but just plainly speaking, this is what I can tell you. So what we are going to persist here is the e variable, which is going to increase that index that we have in our array. And every time we say return X element, that is what we're going to have as the next element and the next element. So we're not telling it, give me all those elements and apply that function. It's just every time I want, you will give me a piece of that data structure and then another and another. And that is how we're going to try to implement these iterators. Normally, these are built in the language, like in common structures such as objects and arrays, but this is how it works. And generators are something else that help us to create functions that can be paused. So the only thing that you can create this function is to add this asterisk and use the yield, that is a word reserved for telling that you need to pause that function and return to what you are delivering. And the next time you call us with next, then we're going to keep on the context of execution. So we're going to analyze what is going to happen when we read all this code. Since we have a function declaration, all this code is capsuled to a function called create flow, and to be able to call it, we will have to call that function. So when we call it, we'll have the iterator protocol. So every time we run next, we will look for the next thing that we can pause, and we get out of that context of execution. So when we declare return next element and we create the generator function, the first way in which we can access the code of the function is calling next. The following line, .next, we're going to enter the context of execution of create flow, and we can see that a variable called num is created, called with a value 10, and then a new variable, new num, and that there we get out of the context of execution, but we deliver the num variable to the one that was using it. For example, the element 1, which we declared in the next to last line of the code, that's going to receive the 10 that we declared in the generator. So in line number 3, nothing is assigned because it is out of the context of execution. So when we call it in the last line, the .next with an element 2 with a value 2, the new num is going to be added with a value of 2 because now it has a context of execution, and now now the value can be added from right to left. So the next time that we get out here, this yield value is going to be 5 plus 1, and it's going to be assigned to element number 2. This is a little bit complex if you don't understand how these kinds of functions work, but it is worth that you understand when do you get out of the context of execution and when do you return to the context of execution to be able to have this new way to have possible functions. So what is this good for in an async await? This is where we can say, what would happen if maybe wait until I have a response from our server, and then we can continue with your function. This is the concept behind async await. If you look at this here, we will have a function that is return next value, in which we're going to call it next when we receive the information from our back end. So in our generator, the create flow, we're going to get out of the context of execution, returning the promise of the API users. So to understand this a bit better, we're going to go to the first declaration of the constant, which is return next value, in which we're going to run our generator. Since we're only just executing it, we need to use the function next to be able to understand the context of execution of that function and wait until it is completed. So now in that second line, when we create the const, we're going to have the future data. Now we're going to call .next that we already gives us access to the context of execution and the API users. Since we have an API users and we're going to return it to future data, and the value of the promise is assigned to future data to be able to assign a callback as we saw in the promises. The last line is a little bit complex because you have to understand how the generator worked. It has an iterator pattern in which you can return a value and then complete it. Since we want to add a callback to that promise, we will need to access through that iterator protocol by means of the dot value. So what we're saying is future data dot value dot then grab the data that we have, and when you receive it, please continue with the function that we have and print the console log of our generator. That is the entire concept behind async await and how it works. And if you look at these 8 lines that look very complex, if you want to use this behavior, just use a prefix to your function and just async. And in another part of your code, like it was synchronous code, you can place an await. But you have to really understand that it's not going to happen as if it's going to be synchronous code. It's just happening behind, but we have a synchronous legibility, but an asynchronous execution. So here we are going to finish our little talk about how synchronicity works in JavaScript.